Okay, it's time to replace the disc in the bandsaw. It is 2.5 inches in diameter and about 100th in thickness, and with use it has become quite ragged in appearance. This is a 3-inch bar of 8620. I faced off the front at about 135 RPM, primarily because it was quite ragged as well. And then the OD is also somewhat irregular, so I've been gradually turning it down. Right now I have cleaned up the face, the OD quite a bit, and so I'm taking about 40 thou depths of cut. This is at 205 RPM and a feed rate of 5 thou per revolution. Next we're going to use a ground insert and see if we get better finish. Shallower depth of cut, 15 thou this time. Let's do a little bit of facing now. Alright, let's see what the stick out is on. The blade itself is, or the insert holder is 1.64, 65, and if you include the tip of the insert, it's about 1.69. Okay, everything is locked down, and we will see where we get with this. You can feel the ruler catching. Since I put the chamfer in there, I could not use the thumbnail method, scraping the old nail, which normally works very well. Alright, we need to go 100 thou. Not very well at all. Okay, well that last tool was a bit of a disaster, so we're going to try something completely different. We're going to do some tailstock support and much better chips, much better. I'm just doing hand feeding right now. Well, that's about as far as we could get, and now it's time to use the old bandsaw. Okay, here's a raw result from cutting with the old Harbor Freight bandsaw, and it's not bad really. The reason why there's this change in the cut is because I started cutting from one side and I thought it was going to get too close to the edge here, so I just rotated the whole piece about 180 degrees. But you know, for a cheap old Harbor Freight bandsaw, it's not bad at all. Next I'm going to use a back support for the part. As you can see, the finish is excellent. I'll go ahead and put that in and tighten things up and see if we can just face off the front. from the saw cuts. Right now I'm doing manual feed. Alright, this tap follower is reversible. I undid the back, pop it out and put it in this way, and hopefully that will provide me the support that I need for my tap, like this. Okay, let's get this going. According to some statistics, 632 taps are the ones that are the most frequently broken. So let's see if we can avoid those statistics. I think that should be deep enough. So I'm going to use a square and put it up on my back vice jaw, line it up with the hole in the part, the calculated RPM is 60 RPM for mild steel. And I'm going to try to go slower than that, but the slowest I can go is about 40 RPM on this machine. Okay, let's see how it goes. Almost to the center hole. I think I'll go about 100 thou beyond the center. And all the way through. And here's the result. The machine says it can go as slow as 40 RPM on the lowest gear settings, but I was really unable to make it go reliably anything less than about 60 RPM. I took some more measurements, and my bandsaw can accommodate a 3/4 inch blade, so I think I'll have to extend the slit by another 200 thou to a total length of 1.55 inches. And okay, this is the final result. We're going to check out the size of the slit. The size of the slit is 62.5 or 63 over here at this end, and the first point of entry is now 72 thou, and remember the slitting saw was 64 thou. And here's the new disc in place. There's a little bit less clearance on the far side than I would like. I may have to take a file and open it up a little bit. And here is the old one for comparison. Okay, so I had to put it back in the mill and use a 1/8 inch end mill to increase the width of the slot. And now there's much better clearance.